Hello everyone, here I am Vadel Sagar, and let us continue our discussion about the chapter number 1, standard 12th, electric charge and its field, chapter number 1 of the physics portion. Okay, in the previous discussions we discussed about some Coulomb's law and its multiple charges and one example also for that. Here we are taking today two examples. The example number 1.5, if you have a textbook with you, that is a better way you can see and understand what I am trying to say you. Example number 1.5. Okay, what the example number 1.5, a charged metallic sphere A is suscepted by the nylon thread. As you can see in the diagram, the one sphere we have, it is suscepted with the one thread. Another charged metallic sphere which is named as B, which is holded with the help of some insulating material, brought closer to the A and B by the 10 centimeters. So this A and B is separated by the 10 centimeter as shown in figure number A. The resultant repulsion of A is noted because both are positively charged, and we know the similar charges are always repel. So you have to find the repulsion force between it by the shining of beam of lighting, measuring the deflections of the shadows and on it. The sphere A and B are the touch. Now the second task. The A and B is the touch with the uncharged. Like there is no charge on the C and D sphere, as you can see in the diagram respectively. You can see. Now the C and D are the remove while it's touch on the B and A. What happened when it's removed? We are capturing at the 5 centimeter. I will show that diagram also. And what we have to find, this is all about what is given. The sphere A and C and sphere B and D have identical in size, so ignore the size of A and B comparison and find the forces between it in a respective cases. Number A, when it is separated by the 10 centimeter, when it's separated by the 5 centimeter. Let us start our discussion. Let us original sphere, the sphere number A, whose charge is, suppose we don't have any idea how much charge on it, so we are taking as a sphere A is a chargify as a Q. Sphere B is also having charge which is different than the, it can be different than the Q A1, so that's why I'm taking as a Q prime, as you can see here. And these both are separated by the distance r. I know in a first case they are separated by the 10 centimeter, but I am taking a r. At the end, if I want, then I will put the 10 centimeter of it. The magnitude of a force, as we know, the Coulomb's law, F is equal to K Q1 Q2 upon r square respectively. So here K is equal to 4 pi epsilon 0, 9 into 10 to the power 9, we know that. Q is the charge of the A, Q prime is the charge of the B sphere, and it's separated by the distance r square. This is the force between A and B in earlier cases when they are separated by the 10 centimeter. Okay. Now, when A is touched by the C sphere and the B is touched by the B sphere, then what happen? When uncharged sphere, when we touch, we know that the charge is transfer on that sphere also, because it is called induction. There the charge always transfer. So there, if the A sphere, here you can see, when your A sphere touch with the C and D sphere touch with the B, and the C and D are both are uncharged, but the A and B is a charge respectively, so they are transferring the charge on the respective C and D according A and B, so they are exactly half of it. If the charge on the A sphere is Q, then when it touch to the C sphere, they are getting the equal charges on both of the, so A is also getting a Q by 2 and the C also getting charge Q by 2. So this total Q on the A, it's equally divided on the both sphere. Same in the case of B and D. The what charges are the on B sphere is equally distributed on this D. So it is Q by 2 by Q by 2 in individual cases. So when it brought, now when you detaching, now it's after the removing the C and D sphere, it is separated by the, we are not keeping as 10 centimeter, we are keeping at the 5 centimeter. Now we are trying to see that what happened, the force it is. Okay, now now they have a, again this new force between the A and B is F prime, which is the K 4 pi epsilon 0. Now the charge on A is As we know, it is going to be half, so we are taking q by 2, not a q. Now charge on B, it is q prime by 2. Okay, and also as we know, the distance is also going to be half, 10 to becomes 5. You can put the respective numbers also in, you can also calculate, and if you take the r is a 10, then phi is equal to r by 2 only. So that's why all it, if you are just solve this is a r by 2 square, so it will be 4, and here is a 4, this 4 is cancelled, this formation is as looks as what we have earlier. So when charge is going to be half and also distance is going to be reduces to the half, the force feel by the respective spheres is not changed. That conclusion we made here. This examples gives a better understanding of the Coulomb's law. Okay, now let us go for the example number 1.6. Consider a three charge q1, q2, q3 on each are at the equitriangles angles at the edge of the ABC, and at the center of the centroids of the equitriangles, it is a respective charge is capital Q. Now what we have to find, consider a charge q1, q2, q3, and then q at the vertices of the equal triangles whose side is L. So the length of this side of the triangles is L. What is the force on Q? Yes, what the force feel by the Q? As we know, the any one charge and respective other charges are also present, they all are giving their forces on that charge. According what our last discussion, you can very well able to calculate these things. For that you just need the separation between it. So here one, the Q is there, this charge is also applying force on it, this charge is also applying force on it, this charge also applying force on it. Now the separation between this CQ, BQ and AQ we have to find, and just we have to put the respective charges and r square by 2, then all about the calculations. Now we know only this distance L. So now our first task in this example, we have to find this distance. This AQ, BQ and CQ all are same. You can say CO, BO and AO is all are same. So one of you can find, other is considered. Okay, now trying to see here. As you can see in this triangle ADC, ADC triangle focus, and I am taking this angle, I'm applying cos on it. What happened? Cos is equal to side and its hypotenuse. The side is equal to AD cos 30, because we know that equitriangle is having 60 angle. This is 60 angle, but I am taking this small, this is a half of it. Thus cos 30 is equal to AD by AC. Then this is AD by AC is AC goes up, the AD is equal to AC into cos 30. What is AC? We know AC is equal to L and cos 30 is equal to under root 3 by 2. So the AD can be, this AD can be under root 3 by 2 L. Is it okay? Again I am repeating, I am taking this triangle and here this is angle. I am applying cos on it. This is a side and this is hypotenuse. So the AD by AC, but AC goes up, so the AD is equal to AC times cos 30. This under root 3 by 2 into L time is equal to centroids of it. Now once we know AD, we can able to judge this AO. As we know in this earlier in this mathematics also, the center of this one of this side AO is a 2/3 of the one of the whole. So this AO can be 2/3 of this AO. This is AO should be 2/3 of AD. So AD, you know, AD is equal to under 3 by 2L. You can put here, you will get this result. 1 upon under root 3 times L is the distance of AO, BO and CO all are same. Again I am repeating, 2/3 of AD. If whole AD you know, the 2/3 portion is this. Trying to understand, okay? And 1/3 is this. So we know this, we have to find these things, so 2/3 of AD. Once you know AD under 3 by 2, you can put the value of here, the under root 3, under root 3, under root 3 left, 2 cancel, then 1 upon under root 3 times L. So once we know the distance of between these and this is our task is over. Now force F1 on Q due to the A. Now A is there applying force on the Q in the direction downward, okay, as we know. Now what actually our data says, 1 upon 4 pi epsilon 0 charge this and this is q charge q, this is capital q divided by distance, and distance is 1 upon under root 3 times l square. Then 1 upon under root 3 square is equal to 1 upon 3, and then the numerators denominator goes up, so it is a up and l square. Again I am repeating one time because everywhere is same as that, there I am not putting effort for that. Again, if you want to find the force between this charge and this charge, you have to applying Coulomb's law. 1 upon 4 pi epsilon 0 q1 q2 upon r square. Here your r is the AO. What is your AO? 1/3 upon under root 1/3 1 upon under root 3 times L. This is your r. You can put at the denominator. What is your q1? Is q only. What is your q2? It's capital Q. So the 1 upon 4 pi epsilon 0 q capital Q small q upon 1/3 1 upon under root 3 times L and square. This is going to be 1 upon under root 3. It is under root 3 is the 3 square, so it just goes up, and L square is still dominating. If you can see the at all where it is same scenario we have, but AO force F1 force is downward, this force is this direction, and this force is this direction. If you applying the parallelogram on F2 on F3, you can do same for this. If you applying parallelogram, we know these things. This is the force vector, this is also force vector. If you applying parallelogram, the F2 plus F3 can be this one, resultant directions. So here I am putting this effort only. The resultant force of the F2 F3 should be like that, sum of its, and this is the upward direction. Okay, you can do some. See, this is 4 pi epsilon 0 4 by 3 epsilon 0 epsilon 0, and this is a resultant force. We have resultant force. Now applying before, this is upward. Now one force is upward and one force is downward. Resultant force should be 0 because all forces are same. This one can dominate if the upward force is more than the downward force, then one can be dominant, but the all forces are the same. This force and this force are resulting force is upward, so that upward force is nullifying the downward force which is applying by the AO. So the result of the force feel by the charge which is seated in the centrioids is 0. It is clear by the symmetry of the triangle, the forces are nullifying each other. If you have any kind of query in this discussion, you can ask, I will solve, and you can contact me on WhatsApp also, as we know. Thank you very much.